So in this video, I'm going to take you through the substitution method. So in our last lesson, we just started looking at what a simultaneous solution is, and we can either draw the graph and find where the two lines meet, or we've got two algebraic ways of doing it. So we've got the substitution method, which is what this video is on, and then the second one will be the elimination method. So before I go through the substitution method, I'm going to go back into Desmos and have a look at these two equations, which will be our first question. The line 2x minus 3y equals negative 8, which this is graphed in red, and the line y equals x plus 3. There is only one point that both lines have in common, and that is our point here at negative 1 on the x-axis and 2 up. So at the point negative 1, 2. So we would expect that to be our answer. When x is negative 1, y is 2. That's the only combination of x and y values that satisfies both lines. So let's have a look at the example that we've got. So coming down here, I have these notes here. So in your summary book, it'd be really good if you could just put the heading, solving simultaneous equations using the substitution method. I've just briefly told you what a simultaneous solution is. It's a solution that satisfies both equations. So on this little diagram, it's this point here. So sometimes it's written as an ordered pair, the xy combination. Sometimes your solution can be written as x equals whatever x is and y equals whatever its value is. Okay, so that's our solution. If you are asked to solve, you are finding the solution that fits both equations at the same time. That's why it's called simultaneous. So our first method is using substitution rule. And so what they've got here are two equations. The 2x minus 3y equals negative 8, well, that's sort of written with x and y on the same side. The other equation has y equals and then everything else on the other side. So the method we use for substitution is when one of your equations says y equals or it says x equals. They both could, like in part B that we'll do, but in this case there's only one equation that is of the form y equals something. That makes it really easy to substitute that equation into the other. So for this one here, I take my two equations, 2x minus 3y equals negative 8, and I call that equation 1. And with the second one, I've got y equals x plus 3, and I call that equation 2. Now the person looking at your work needs to be able to understand how you arrived at your answer. So we use just a few little words. So we don't write substitute, I just write sub. Equation 2 is the one that has the y equals, so I'm going to take equation 2, so I'm going to sub 2 in 1. That's enough of a description to explain to someone looking at your work in what you've done. So what I'm going to do is, in equation 1, that's where y is. But instead of y, we know from equation 2 that y equals x plus 3, so I'm going to substitute x plus 3 in wherever there was a y in the first equation. This might be a bit confusing to start with, so sometimes you need to try a few to get used to it. So I said I'm going to sub 2 in 1, so I'm going to write out equation 1, 2x minus 3. Now instead of y, I'm just going to put a bracket. And whatever y equaled, so instead of y, I'm going to replace it with this thing here. So it's x plus 3. The rest of equation 1 said equals negative 8. Okay, so I've got 2x minus 3, instead of y, I've replaced it with the x plus 3, equals negative 8. And from here, you just want to expand your brackets and solve for x. So because I've gotten rid of the y, because I've substituted for y, it allows me to work out the other variable. And once I've found x, I can put that back in either equation, but I will choose 2 because it's simpler to get the y value. So we've got 2x minus 3x. This is going to be minus 9 because it's negative 3 times positive 3, and on the other side negative 8. If I put my x terms together, 2x minus 3x is negative 1x, which is negative x. And I'm going to move my negative 9 to the other side by adding it. So if I've got negative 1x equals 1, because negative 8 plus 9 is 1, and I want positive x, I've got to divide through by negative 1. So the value of x was actually negative 1. Your next step, now that you've solved for x, we call that 3. We write down what we're going to do. We're going to sub number 3, equation 3, in, and it doesn't matter which equation. They will work for both. I'm going to choose equation 2 because it looks like less working. So you can be a little bit smart about that. So equation 2 was y equals whatever x is plus 3. So y equals, we've just found that x is negative 1, and it said to do plus 3, so y equals 2. So therefore our solution is that x equals negative 1 and y equals 2. And that was the same point that I found on Desmos. So when x is negative 1, y equals 2, it satisfies both equations. So if I just briefly go back into Desmos, you'll see that was the point, negative 1 on the x-axis, 2 on the y-axis. So that makes sense. Okay, so that is our first example. And then in B, just means that both equations are written as y equals. So that's okay, we're going to still sub one equation into the other. So let me start part B. So in part B, I write down my two equations. Y equals negative 3x plus 2 and y equals 7x minus 8. First step, label them equation 1 and equation 2. I'm going to sub, and it doesn't matter which order because they're both y equals, so let's just write sub 1 in 2. So you're explaining to the person looking at it what you're doing. So instead of in equation 2 writing y, we know from the first equation it equals negative 3x plus 2. So I put negative 3x plus 2 in for wherever there was a y into the second equation. The rest of equation 2 said 7x minus 8. Now that it only involves x, I can solve for x. You can get your x's on whatever side you'd like. I'm actually going to switch my sides around because it looks like it might make it a little bit nicer in terms of the negatives. All I've done is swap the left-hand side with the right-hand side. Bring all my x's to the left. So 7x, when I bring over minus 3x, you do the opposite. You add 3x. And on the other side you've got 2, but when you bring the minus 8 over, you will do the opposite and add 8. 7x and 3x is 10x. 2 plus 8, 10. And if you divide both sides by 10, I've got my x value. Now just like before, once you get your value for x, call it 3. And we're going to sub 3 in. You can put it in equation 1. You can put it in equation 2. Doesn't matter. Let's try it in 1 this time. So equation 1 says that y equals negative 3. Now instead of x, we've just worked it out. So you times it by 1 and then add 2. So y equals negative 3 plus 2, which has a value of negative 1. So therefore our simultaneous solution is that x equals 1 and y equals negative 1. And as I said, you can write that as an ordered pair if you want to. So I can either write it that way, or my solution is at 1, negative 1. Make sure you put the x first, and then the y. So that's solving using substitution. And exercise 1I, I think it is, has the relevant questions that get you to practice that technique.